Welcome back to another explainer. So today we are tackling a massive shift in how we actually interact with our software. We all know the problem, right? Manual, repetitive tasks on our local systems and jumping between apps just completely drain our productivity. We've been practically begging for a solution, an AI that doesn't just sit there and chat, but actually does the heavy lifting for us. Well, that solution is finally here, and it has absolutely exploded onto the scene. Today, we're going to demystify the intense hype, the real operational impact, and crucially, the hidden dangers behind the OpenClaw phenomenon. Let's get into it.
Okay, first things first, we gotta talk about this bizarre naming collision that's been confusing developers everywhere for the last few months. If you've been poking around GitHub lately, you might be wondering, what on earth does a 1997 2D platformer game have to do with a $116 million OpenAI acquisition? It's kind of a wild connection.
Let's just clear up this confusion right out of the gate. On one side, you have the OpenClaw game engine. This is a super passionate, open-source C++ re-implementation built to preserve this classic 1997 game called Captain Claw. Awesome project, but totally unrelated to what we're looking at today. Because on the other side, we have the OpenClaw AI agent. This is the 2026 autonomous Node.js framework that went so incredibly viral that its solo developer, Peter Steinberger, was just hired by OpenAI for a reported $116 million. So yeah, two very different beasts, sharing the exact same name.
All right, let's dive into Section 1, the architecture of autonomy.
To really grasp why this AI agent is such a game changer for our daily operational efficiency, we have to look under the hood. The whole system revolves around something called the gateway. This is a single, long-running process that lives right on your machine. So instead of you having to open up a web browser to go chat with an AI, this gateway sits there, receives network socket messages, and routes them where they need to go. It sets up the session, loads your local skills, and essentially acts as the ultimate bridge between the large language model and you, the user.
And what's genuinely fascinating about this setup is where this AI actually ends up living. Because of that gateway process, you don't need some clunky, dedicated dashboard. OpenClaw routes directly into the communication channels you're already using every single day. We're talking Discord, WhatsApp, Telegram, Slack. It transforms from a standard web tool into an always available, highly capable assistant that's literally sitting right in your pocket.
But, true autonomy means it shouldn't just sit there twiddling its thumbs waiting for you to tell it what to do. OpenClaw can act entirely on its own. Obviously, yes, you can send it a direct message, but it can also be triggered by regular heartbeats, basically just timer intervals. You can hook it up to scheduled local cron jobs, or it can instantly wake up via webhooks the exact second a specific local or remote event happens. It's literally managing your workflows while you're fast asleep. How cool is that?
Moving right along to Section 2, Windows 11 setup and execution.
So how do we actually go from having this problem of needing a smart assistant to the impact of actually having one running on our machine? Let's walk through a typical step-by-step local Windows 11 setup. The community has made this amazingly streamlined. It all starts with just a single PowerShell command you can grab from the official site. You run this, and it automatically detects and installs Node.js. We're talking version 22.22.0 or so if you don't already have it. Then it pulls down the OpenClaw gateway and fires up an interactive onboarding wizard. Sounds super easy, right? Well, actually, a lot of Windows users end up hitting a major roadblock literally at step 1.
Yeah, so the crucial thing to watch out for here is Windows security protocols. You're almost certainly going to get hit with a running script is disabled error right there in PowerShell. It's super common. To fix this, you just need to open PowerShell as an administrator and run the set-execution policy command. Once you do that and hit Y to accept, you bypass that block and your installation can keep moving forward smoothly.
Okay, so OpenClaw is installed. Now you need an actual AI model to power the thing, right? Hooking it up to Llama is a massive cost saver for local setups. But there is a very specific friction point you absolutely have to watch out for. Because the initial OpenClaw setup wizard automatically starts a gateway in the background, you have to hit Control-C in your terminal to close that active process first. You can only have one gateway running at a time. After you kill that process, you can download the Llama executable, sign in, and then launch OpenClaw natively using the specific Llama CLI command for whatever model you're trying to use.
And guys, this perfectly illustrates the end-to-end impact of having this tool on your system. Once it's running locally with a powerful model like DeepSeek or Minimax, you can literally just type into your WhatsApp or Discord chat, "Hey, identify the hardware specs of my machine," and OpenClaw will independently write and then execute background PowerShell shell commands on your Windows system, parse all the messy output, and just hand you a clean, formatted summary of your CPU, RAM, and BIOS. That is absolutely next-level operational efficiency.
All right, let's jump into Section 3, explosive growth and costs.
When a tool solves a major problem that efficiently, people are going to notice. 346,000. That is the number of GitHub stars OpenClaw racked up in under 5 months. Just to put that massive number into perspective for a second, it completely blew past legendary, foundational libraries like React, which, by the way, took over a decade to reach 250,000 stars. It is officially the most starred software on all of GitHub. Unbelievable.
And, as you might expect, those stars translate into some serious real-world usage. We're talking over 500,000 running instances globally right now. When we look at how professional users and teams are deploying these agents to manage multiple instances and maximize scalability, Docker Compose is absolutely dominating the space at 65%. It's really established itself as the industry best practice here, followed up by native NPM installs and Kubernetes.
Of course, getting this kind of efficiency does come with the price tag, but it's actually surprisingly manageable. Now, enterprise users might just opt for managed services that start around $19 a month, but for the self-hosters out there, you can optimize your VPS and API costs brilliantly. You can spin up a budget setup for literally just $8 a month. Even the heavy power users who are just hammering API requests peak at around $60 a month. When you think about the return on investment for completely automating your local workflows, those numbers are just fantastic.
Which brings us to the very serious Section 4, severe security vulnerabilities.
Look, with great autonomy comes some pretty terrifying risks. Remember those 500,000 global instances we just talked about? Well, security researchers recently found that over 135,000 of them were actively, publicly exposed to the internet. And it gets worse. More than 50,000 of those were directly vulnerable to remote code execution, meaning a hacker could essentially take full control of the host machine with a single click. Let that sink in.
Probably the most sinister threat we're looking at here is a prompt injection attack. Think about it like this. Imagine you tell OpenClaw to just go out and summarize a website for you. Sounds harmless, right? But if that site contains hidden, malicious text specifically designed for an LLM to read, your local AI agent will read it, adopt those hidden instructions, and then use its elevated permissions to execute harmful commands directly on your local hard drive. This exact threat is literally why Mac Mini prices shot up recently. Power users were going out and buying completely separate, physically isolated computers just to run OpenClaws safely without risking their main personal files. It's crazy.
Things really reached a fever pitch in the spring of 2026. During what the community now calls the March vulnerability crisis, 9 critical CVE vulnerabilities were disclosed in the span of just 4 days. And one of them, it scored a horrifying 9.9 out of 10 on the CVSS scale. To make matters even worse, researchers flagged over 800 malicious skills lurking in the community Claw Hub, with some third-party tools actively caught exfiltrating user data completely behind the scenes.
So, if you are going to leverage this incredible operational efficiency, you absolutely have to follow some strict security best practices. First, never ever run OpenClaw with full host privileges. Use a strictly sandboxed virtual machine or a dedicated Docker container. Keep all your API secrets entirely out of the agent's reachable file system. Make sure your gateway sits behind strict authentication. And honestly, above all else, apply patches constantly. The team had to release 13 patches in March alone just to stop the bleeding. You gotta stay updated.
There's this quote from an OpenClaw core maintainer, known online as Shadow, and I think it really just hits the nail on the head. They said, if you can't understand how to run a command line, this is far too dangerous of a project for you to use safely. It's a massive, sobering reality check. OpenClaw is not just some fun, quirky chatbot. It is a highly capable system executor, and it requires a significant amount of technical maturity to manage.
Which really just leaves us with a critical question to think about. The operational impact of OpenClaw is undeniable, right? It can fundamentally scale how you work by completely automating complex local workflows directly through the messaging apps you already use. But is the ultimate convenience of a fully autonomous AI agent truly worth the ultimate vulnerability of your local system? That is a very high-stakes trade-off that every developer and power user is going to have to weigh carefully. So what do you think? Thanks for joining me on this explainer, and as always, keep learning. I'll see you in the next one.